We're going to talk about vertical and horizontal asymptotes here. We have a function y equals 1 over x minus 1 plus 2. Now, asymptotes are a really interesting topic because of the way they behave. So if you'll notice here, we have a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 2. So the reason for this is because in this function we have 1 over x minus 1. So if x is 1, then this denominator of the function becomes 0, and we can't have a fraction anything over 0, so x can't be 1, and that's why this function never actually reaches 1. It becomes infinitely close to 1 on both sides, infinitely close to 1. You can get as close to 1 as possible. It can be 1.01, 1.00001, 0.99999, but it can never actually be 1. So we have this vertical asymptote here. Additionally, we have a horizontal asymptote because this fraction, again, it can't ever equal 0 because we have 1 over some number. So it can be super close to 0 if this denominator is really large. This is going to be a really, really small number, making this really close to 2. But this can never be 0. And because of that, it can never be 0 plus 2. Y can never be 2. So we have this asymptote at 2. It can get infinitely close to 2. It can get infinitely close to 2. But y can never equal 2, which is why we have this horizontal asymptote here. Now, when you see these questions on tests, generally the way it'll look is it'll say something like this, and maybe we'll pick whole numbers to make this a little easier. If I show you this function, this graph, can you tell me the equation? Well, we know that this function here kind of represents 1 over x, right? But notice there's a vertical asymptote at x equals 2. X can never be 2, so it's 1 over x minus 2, right? Because x can't be 2. But then we also have to account for this horizontal asymptote. This horizontal asymptote at y equals 5 says y can never be 5. So we have this number that's not 0. If we add 5, y can never be 5, right? So it kind of works both ways. It's a really interesting topic. Again, so you can be given a function and analyze the function and say, okay, there must be a vertical asymptote here at x equals 2. There must be a horizontal asymptote here at y equals 5. Or they could give you a function down here and say, you know, here's the vertical asymptote, here's the horizontal asymptote. Here's a list of functions, which function makes sense.